Hey everyone, we are looking at something called Riemann sums. You see that name? It looks like it should be Riemann or something, but it's actually pronounced Riemann. Kind of like, you know how Einstein is EI, but you pronounce the I, not the E? It's that second vowel thing. Yeah, the same kind of rule. Anyway, so these Riemann sums are a way to calculate a definite integral. Remember way back in chapter 1 when we were looking at areas between a curve and an x-axis and we had to horribly count boxes and it really was horrible. And then we are like, oh, let's do some trapezoids instead. Well, same idea, but this time it's rectangles. And as a memory trick, Riemann and rectangle both start with R. So if you see, like, find the Riemann sum, you're like, oh, Riemann rectangle, they start with R. I got this. So I have to make things up because I can't remember anything. Okay, so it's just replacing the box counting and trapezoids. So a bit of notation, if you see that integral sign like we learned about last week with a number at the bottom and a number at the top, this is your lower bound, it's on the lower part. And this is your upper bound, it's on the upper part of the integral sign. And it's just the x values that you're starting and ending with. Oddly enough, it can actually go the other direction. Like you can have an integral from, like, say 2 to -5. It would mean going right to left, which if you go right to left, it means your change in x, you're moving to the left, so it actually changes the sign. We'll get more into that later. So also you can have negatives when you're below the x-axis, and we learned about this back in chapter 1. So like that little bit underneath the x-axis, that part of it's negative. So like if you look at the integral, the value of the integral for a sinusoid from 0 to 2 pi, that actually is 0. Kind of trippy. Anyway, so there are different types of Riemann sums, so let's look at them. Okay, so the first one is called a left Riemann sum. So I've already drawn in my little strips. These strips, the width of them are the dx's. It's the change in x. So that dx that you see on the integral sign, what you're really saying here, we have this, the integral looks like an S for sum. You're saying take the height, the y value, and multiply by the width of the strip. And then the S for sum means add them all together. So you're saying take these strips, multiply the height by the width as a rectangle, and add them together. That's really what this means. So a left Riemann sum would be, if you have all these strips, if this is a scale of 1, I know these graphs have no numbers, but say it's by ones. All my dx's equal 1. In this case, a left Riemann sum means for the height of your rectangle, start on the left edge of the box. So like here is my height. And so, yeah, I know I messed up, and it seems like I messed up because I don't have that triangle included in my area. The area of this first rectangle is 2, when really the area of that strip is more. We'll get into that error in a second. Let me first just keep drawing. So, oh, but wait, I have extras now. I have this extra bit added in, and more extra bit when I start on that left. And then, oh, a little got cut off. But if I have really skinny strips, those errors, those bits added and, omitted or, included, excluded, whatever, it kind of balances. It doesn't really matter if I have really skinny strips, because if your strips are skinny enough, you're not going to have any sort of error. In fact, as the number of strips goes to infinity, this number that you get from this Riemann sum actually gets to this perfect exact answer. We're going to learn about how to get that exact answer in a little bit. So a left Riemann sum simply means start on the left edge. You can probably guess that a right Riemann sum, I'm going to go to the right part of the page, start on the right edge. So instead of starting at 2 for the height on this first strip, I'm actually going to start at 3. I'm going to the left, going like that. So if you start on the right edge, that would be your right Riemann sum. You can probably guess what's going to be in the middle. This is called a midpoint Riemann sum that I'm about to draw. So I'm going to go to like the 0.5 mark and make that my height. And I'm going to go here for my height and here. So I'm just going to like the 0.5 mark of the strip, and I made a midpoint Riemann sum. Here's the weird part. You can over and underestimate all over the place with this, but again, as the number of rectangles goes to infinity, these three numbers that you would get if you add them up would actually all zoom in on the exact perfect answer. So these are left, midpoint, and right Riemann sums. You can start anywhere. It's kind of weird. These are the most common. There are two others, though, called lower and upper. And this actually you have to think a lot harder because you have to, so for a lower Riemann sum, you look at each strip and you say, what's the lowest y value? That's going to be my height. Bam. So in this case, I start at the first bar, I start on the left edge, second bar, still on the left edge. The third spot, I'm on the right. The fourth, I'm on the right. And I'm going to alter my graph a little bit just so I can make a point. Let's say it goes something like that instead, just so I can make a point. While I'm at it, I'm going to make another point with this for when I go to the upper. So like say it goes like that. It doesn't have to be a pretty graph. I'm just making a point. Okay, so a lower Riemann sum, I would go to this bottom part. And you might be thinking, why would you ever do a lower Riemann sum? That answer is clearly wrong. Or if you look at the upper and you start on the high spot, I know these are no longer the same graph. We'll pretend they are. So if you go to the highest spot, like why would you ever do an upper Riemann sum? This is clearly too small. This is clearly too big if I actually, found those areas. If I wanted to, I could average them out. That would probably get pretty close, wouldn't it? That's kind of cool. But here's the weird deal. If I have more rectangles instead of 5, if say I had 50 or 500 or a gazillion, as the number of those rectangles goes up, the number of strips that I have goes up, these two numbers that I would get for these sums would actually go to the exact same number. So again, no matter what, if it's left, right, midpoint, lower, upper, whatever your way across, as you have more and more rectangles, so instead of 5, you have 5,000, the answer that you would get would all go to the same exact number, where that number is the exact perfect 100% accurate answer. So in the next video, you're going to learn how to put a program into your calculator that a program can do left, midpoint, and right Riemann sums. In certain conditions, it can do lower and upper, but you have to be really careful on that. So these are the Riemann sums and the most common types. But again, as you have more rectangles, you get to be a perfect answer. And the actual perfect answers, we won't use Riemann sums, but this is building the concepts so we understand what's going on. And eventually we will get to perfect exact answers.